Welcome to Study Loop.
For this problem on the topic of waves and sound, we are told that two sources of sound are located on the x-axis and each source emits power uniformly in all directions. We are told that one source is positioned at the origin and the other at x is equal to positive 123 meters. The source of the origin emits a power that is 4 times greater than the other source. We want to know where on the x-axis the two sounds are equal in intensity, and we had to note that there are two correct answers. So because source 1 is more powerful than source 2, both locations of equal sound intensity will be closer to source 2 than to source 1. So one point will be A, as shown in the diagram, which is between the sources, and the other B, which is in the opposite side of source 2. So we let the distance from source 1 to point A be x, and D be 123 meters, the distance between the sources. The intensities I1 and I2 of the sound can be found from the equation I is equal to P over 4 pi r squared, where P is the power output of the source, or the sound power, and R is the distance between the source and point A. Now, the sound intensities are equal at point A, so we have that I1 must equal to I2, which means that P1, the sound power by source 1 over 4 pi R1 squared, must equal to the sound power of 2 divided by 4 pi R2 squared. Now we know that the power P1 emitted by source 1 is 4 times greater than that emitted by source 2. So we know that P1 is equal to 4 times P2. So in equation 1, we'll call the first expression equation 1, we can set R1 equal to x and R2 d minus x when A is taken as the point of equal sound intensity. And we can also say that x is the position of point B relative to the origin, so that R2 between source 2 and point B would be R2 is equal to x minus d. So we can choose either one. And since R2 squared is d minus x all squared, which is the same as x minus d all squared. So if we substitute, and remember our power equation, we call it equation 2. So if we let R1 equal to x and R2 be d minus x, and we go to equation 1, we get 4 times the power P2, which is P1, over 4 pi x squared is equal to P2 over 4 pi into d minus x all squared. So we see the 4 pi's are common on either side, the P2's are common on either side, and we are left with 4 over x squared is equal to 1 over d minus x all squared. Now, if we cross multiply this equation, we obtain a quadratic equation. So we get x squared is equal to 4 into d minus x all squared, which means that x, if we take the square root of both sides, is plus or minus 2 into d minus x. So this is where our two roots are found, and hence the two answers. So we can solve equation 3 and find two roots, one positive and one negative. So the positive root, if we solve above, x is equal to 2d divided by 3, which is 2 into 123 meters. the distance separating the two sources divided by 3, and we get the first position of equal sound intensity to be 82 meters on our x-axis. The second position is our negative root, and our negative root gives us x is equal to 2d, which is simply outside of source B. So we can see that's 2 times 123 meters, which is at a distance of 246 meters from our origin. So now we have our 2 points at which the sound intensity for both sources are equal.